Hello, pre-calculus. Welcome to section 7. It's chapter 7.1 in our text, but we're going to veer a little bit away from the text because I really like these notes, so I want to see how you guys do with them. All right, so parabolas, this should be a review for you guys. We've done it in Algebra 1, at least the up-down ones. In Algebra 2, we added the left-right ones. I think we talked about it a little bit at the beginning of the year when we were doing polynomials. And now we're going to think of them as conic sections. So we built parabolas using a focus and a directrix, axis, symmetry, vertex, all of that in Algebra 2. So this should be a review. A parabola is the locus of points. That just means a collection of points such that each point is equidistant to a fixed point called the focus and a line called the directrix. So anywhere on our parabola here, the distance between a point and the focus is going to be the same as the point and the directrix. It doesn't matter where we go on a parabola, this distance will be the same as this distance. And that's how the parabola gets its shape. So D1 is equal to D2. If D1 is the length between the focus and the point, and D2 is the distance between the point and the directrix. Both equal. All right, so here's a vertical parabola. It opens up. The focus is always the point that's inside the parabola, and the line on the outside of the parabola is called the directrix. The directrix is not this point, it's this line out here. And the parabola always bends away from that directrix line. The guy in the middle of our parabola is called a vertex. And so the distance up to our focus is the same as the distance down to the parabola, down to the vertex, and that is what we call P. We could do the same thing over here. This is your focus. I'm not going to write it down, but there's your focus. The line is called your directrix. The distance between the vertex and the focus is P. Your distance between the vertex and the directrix is also P. These guys are equidistant. And that's it. So the focus is the point that's always inside the parabola. The directrix is the line always on the outside of the parabola. The parabola is facing away from that line, or from the directrix line. The directrix and the axis of symmetry are perpendicular. So the axis of symmetry of our parabola, remember we talked about this in Algebra 2, is that line that divides your parabola in half. So this solid line here is what divides our parabola in half. The vertex is always P units. Why am I putting absolute value around P? It's P units away from the vertex and the directrix. Well, remember P is a length, and I can't have a negative length. So even if that value is negative, we're going to take the absolute value of it, make it a positive value because it's a length. All right, and then the latus rectum, and this is a new phrase for me, is a segment that passes through the focus with the endpoints on the parabolic curve and has a length of 4p. So latus rectum, Dr. Romero told me, I think I'm going to mess this up. Okay, was termed by or coined by Euclid when he was creating geometry. But we talked about it last year, so you might want to make a star in your notes. We talked about this last year as focal width. And I've seen it only as focal width. This is the first time I've seen it as latus rectum, but I left that on here because you might see it as latus rectum when you get to college. All right, and so when we're talking about latus rectum, we're talking about this line here that's perpendicular to the directrix going through your focus. So from here to here, that's the line segment. Over here would be this line segment, and that's your focal width or latus rectum. All right, so standard form for an up-down parabola is going to be 4p y minus k x minus h squared. So how did we see it in Algebra 2 before we because we talk about parabolas in standard form, and then we go into this definition of the locus and the directrix. And I believe we said it was y minus k is equal to a x minus h squared, where this guy was 1 over 4p, which got it kind of confusing. I like this version of it better, and this is what you'll see when you go forward with advanced math, most likely. And I like it just because it makes that 4p part pretty, not as challenging as this fraction form over here. So it opens up if p is positive and opens down if p is negative. And that 4p, remember, that's your latus rectum or your focal width. And then if we're opening left and right, then this is going to be 4p x minus h is equal to y minus k squared. If p is positive, greater than 0, we're going to open right. If p is less than 0 or negative, we're going to open left. Again, 4p is your focal width. That's the distance across your parabola right at that focal, or at your focus point. All right, so we're going to start graphing parabolas. Again, this should be a review. First thing we can do is we can always pull out the vertex. So it's always the opposite and opposite. So the opposite of this guy for our vertex. So our vertex is going to be at 4, -3. If the x is squared, I know it's an up-down parabola or a vertical parabola. I want to make sure the 4p part is with the guy that's not squared, which it is already set up here. So 4p in this case is equal to 2, which means when we solve that guy, p is equal to 2/4, which reduces down to 1/2. Since our p is positive, this guy opens up. All right, so here is my vertex at 1, 2, 3, 4, down -3. And P is the distance from my vertex to my focal focus and my vertex to my directrix. So I'm going to go up 1/2 for my focus and down 1/2 for that directrix line. All right, and then that focus then would be at 4, not down to -3, but up 1/2, so 4, -2.5. Now the endpoint in the lattice rectum, we're going to go across a parabola at that focus point for a total amount of 2. And so I'm going to split whatever that is up, and I'm going to 1/2 on one side of my focus and 1/2 on the other. So I'm going to go to the left, 1/2 of 2 would be 1. I'm going to go to the right, 1/2 of 2 is going to be 1. And that's the endpoints of my lattice rectum. What are those points? 3, -2.5, and 5, -2.5. So now I've got 3 good points to kind of guide the drawing of my parabola. My axis of symmetry, remember, it is what cuts this parabola in half. That's at y equals 4. Sorry, not y, this here is x equals 4. And then my directrix is this line underneath. Remember, it's p distance away from the focus. Away from the vertex, opposite of the focus. So if my focus is up here, we came down 1/2. This point is at 4, -3, so my directrix is at y equals -3.5. So 1/2 a value more than -3 there. All right, that's number 1. I'm going to try to get through 2, 3, maybe 4. And let's do 2, 3 in the next video, and then we'll do 4, 5 in the video after that.